Hello, in this video, we are going to do a few examples with U-substitution. U-substitution is an important technique of integration that's usually taught in Calc 1. So the first example that we're going to look at is shown here, the integral of natural log of x divided by x dx. So we want to find a u so that du is convenient. So U-substitution is undoing the chain rule. So we need to find a convenient u, and we're going to try natural log of x. So du is then 1 over x dx. So this integral is equal to, now we're going to replace natural log of x with u, and then the 1 over x dx becomes du. So now this initially complicated looking integral is nice and simple. It's just the integral of u du, and we know that that's equal to 1/2 u squared plus some constant. And now that we're done integrating, we can sub back in what u is. U is natural log of x, so we have 1/2, and then the square of the natural log of x plus our constant. So that is our first example. If you don't know what to try for U-substitution, then in a case like this where there's only a couple options, you can try one thing and see if it works out nicely. And if it doesn't, you can try the other one. So you could have maybe tried to see if u equals x works, u equals 1 over x works, but you would find that the derivative of 1 over x is negative 1 over x squared. So this is not going to work out. It's not going to get rid of the natural log. It's just going to make things more complicated. So that is how we chose our natural log of x as our u value. In our next example, we are going to integrate from 0 up to 1 of x squared over 4 plus x cubed dx. Okay, so again, we need to be thinking about the chain rule when we choose our u. So we have a few options here. We could try maybe x squared, or we could try x cubed, or we could try 4 plus x cubed. And we're going to use 4 plus x cubed. And that's because we see this x squared in the numerator. And we know that the derivative of x cubed is 3x squared. And then throwing in the 4 plus doesn't affect anything. Since 4 is a constant, then the derivative of a constant is 1. So we have u equals 4 plus x cubed. We have du equals 3x squared. So this is convenient because we have x squared dx here. We do not have 3x squared dx, but that's okay. We can just divide both sides by 3. And now we can see that we're going to replace x squared dx with du over 3. Okay, when we have an integral with bounds defined, like we do here from 0 to 1, then we have two options. At this point, we can either convert everything to u, or we can do our u sub, return to terms of x, and then evaluate the bounds. These are our two options here. So first, I'm going to show you how to do it the first way, converting the bounds to u. Okay, so our original bounds are in terms of x. And one of our x values is 0. The other x value is 1. So all we have to do to find the bounds in terms of u is plug 0 into 4 plus x cubed, and then also plug 1 into 4 plus x cubed. So we get 4 plus 0 cubed, or 4, and then we get 4 plus 1 cubed, or 5. So what this means is that our integral from 0 to 1 of x squared over 4 plus x cubed dx, this now has bounds 4 up to 5, And now we're going to write the integral everything in terms of u. So this is initially all in terms of x. And now we're going to write it all in terms of u. We do not want to have an integral that mixes x's and u's at the same time. So we said that we have u equals 4 plus x cubed du over 3 is equal to x squared dx. So our denominator is replaced by u, and then x squared dx turns into du over 3. So we have 1/3 du. If we want, we can pull that 1/3 out in front just to get it out of the way so that we can see that we now just have the integral of 1 over u du. And we know that the antiderivative of 1 over u is the natural log. So we have 1/3 natural log of u plus our constant, except we're going to evaluate at our bounds, which are 4 and 5. So we get 1/3 natural log of 5 minus 1/3 natural log of 4 as our final answer. So just to recap, we have converted the bounds of the integral to in terms of u. We did our u substitution. We found the antiderivative of 1 over u, and then we evaluated in terms of u. Now I said that there was another way to do this problem, and let's look at it now. So our original integral was x squared over 4 plus x cubed dx. We said that we're using u equals 4 plus x cubed, and that du over 3 equals x squared dx. All right, so what we're going to do is use this substitution to get 1/3 integral of 1 over u du. Now we do that integration, get natural log of u. And now we're going to convert back to in terms of x. So we're going to replace our u with 4 plus x cubed. And now that we're back in terms of x, we can evaluate this at 0 and 1. And so we get 1/3 natural log of 4 plus 1 plus 1 minus 1/3 natural log of 4 plus 0. So we can see that when we do it either way, we're going to get the same answer. So you can do it either way, either convert the bounds to be all in terms of u and then calculate our integral this way, or you can forget about the bounds temporarily, do your u substitution, find your antiderivative, convert back to x, and then evaluate at the endpoints 0 and 1. Good luck, and I hope that helps.